milliseconds, stuff like that. They don't repaint, right? So just by telling, okay, are these frames slower again, you can tell where these went. He brought back browser history sniffing after this has been fixed since 2010. Really, really creative attack. I didn't know any of the things necessary to know to even think about something like this. This was really cool. Okay, so, but this is just the first part of this attack. So this is where the pixel perfect timing comes in. So he uses some other, another HTML5 thing. Instead of a request animation frame, we're going to do some SVG hacking. Yay, right? So SVGs is great. We can do all sorts of graphic stuff in HTML now. Hopefully Flash goes away, right? Yeah, I'm not holding out hope. So, okay, one of the effects that can be used in this SVG HTML5 graphic magical land have to do with blurring or dilating and eroding are the two that we're worried about, right? So this FE morphology tag. Does anyone know this? I don't know anything about any of this, right? Is this familiar to anyone else? Cool. I don't feel stupid. So I don't do anything with graphic design or anything like that, right? But apparently there's this HTML tag called FE morphology, and you can take an image and you give it the FE morphology tag, and you can either set one of these two options, right? You can either dilate some image, make it thicker, right, or erode it, make it thinner. Okay, but browsers kind of saw this as a potential problem, right? So not all images are equal, right? So some images are really complicated, some images are just really one solid color and not really much going on, right? So they actually developed a more efficient algorithm of FE morphology, so it didn't have to go through every pixel and dilate or erode it. It could just go down the left-hand column of it. If it knew that the picture was a solid color, it could just go down this left-hand column and dilate or erode the whole solid color, right? So the important difference here is that this is much, much faster than that, right? So again, we're going to be using a timing attack. So there's another thing besides FE morphology. There's this other weird graphic HTML land thing that I didn't know about called FE composite, and you can multiply two images together. Because who wouldn't want to multiply images together? I have no idea, right? But the important part here is if you take some noisy image, same noisy image, if you multiply it by an all black image, you get an all black image. If you multiply it by an all white image, you get a noisy image, okay? I have no idea why any of this works. I don't know what it's doing. I don't know a legitimate use of the FE composite operator multiply, but this is what it is, okay? So this is important for this attack, right? So again, going back, right? If it was an all black image, it could do this FE morphology thing much, much faster than the noisy one. And now we know that we can easily, if we create an image that's all black and white, when we do this multiplication, we can end up with an image that's all black or noisy, right? And we can start to figure out these pixels. Okay, so here's the attack. So you create an iframe on a website that you would like to read the information out of, right? So that's obviously bad, right? You don't want some website that you go to be able to frame in some other website that you're not on, right? And that website can then all of a sudden read the data out of it, right? So your cookies, CSRF tokens, things like that. There's going to be your bank. Who wants to frame your bank account or something like that, right? There are headers that make this really impossible for a lot of things, but as you'll see in the demo, there's still a few juicy tidbits in this, right? So what it's going to do is going to take a snapshot in time of that frame, right? Take a picture of it. We don't want that frame changing while we're trying to do this timing attack, right? So we're going to take a picture of it, right? Another SVG HTML thing I didn't know about, threshold. You can turn it black and white, right? You can make this, you can apply this SVG threshold to this snapshot you just took and make the whole picture either black or white. I'm sure Instagram is making millions off this, right? Then you can multiply this whole black or white image that you now have by some noisy image that you have ready to use this for, right? And then profit. Okay, so let's see if the demo gods. This is just a video. I'm not even really trying to demo much. So what you're going to see here, this is the iframe that he's loaded in. It's of his Google Plus comment box. Okay, Google allows you to iframe some comment thing for whatever reason, right? But it has a lot of your information in it. So this is he's logged into Google, he's on some website that's not Google, it's framing in this ability to comment in G+. This, it's going to be hard to see, but this is the pixel in time that he's looking at, and this is him reading it, okay? So I'm going to hit play, and kind of see what's going on here, see if it works. Sweet. Okay, so he's going to hit go. And it's going through pixel by pixel, and this is the resulting multiplication. So it's kind of hard to see on this screen. It's a little yellow here, but that's either black or noisy, right? But it's kind of a darker noisy than it works. And this is him reading pixel by pixel his name out of the iframe, right? Because it was all black and white. Boom, you read his name out of it. Okay, some limitations here. The result is an image. He's creating an image. So this isn't something that you can like feed on a command line to a new tool that can spit something back, right? Like it's creating a PNG file or something that someone has to look at to read the information that's sensitive, right? So what if you wanted to read text out of it and give it to a program and actually start hacking people at scale, right? Something like CSRF tokens or whatnot. Okay, so the thing about reading text instead of pixel by pixel, well, you're going to go pixel by pixel, but if you would like to read text, what would be really helpful is knowing the font, right? You want to know where these pixels are. So something that has a pretty standard font is your source code. It's always going to be the same font. So you can actually iframe, view source, HTTP up the site, you can view the source code of the site, there's the text that you're going to read, right? So things like CSRF tokens and whatnot are going to be in there, and you don't have to do the whole slow FE morphology thing, right? So this is actually kind of cool. So this is a pixel heat map of, if you did the hex character set, for example, right? So we took 0 through F, laid them on top of each other, and that's a pixel heat map of how many pixels are used in all of those characters sitting on top of each other, okay? The red ones are pixels that are used by exactly half of those characters. So you can create a quick binary tree here, all the way down, and now instead of having to read every picture of a font, every pixel of a letter in the font, you can only read like 3 or 4, and then you reliably know, hey, that's one of these. So this is hex. So you need 4 characters. If you read 4 pixels, you can get for definite the hex character. You need 5 pixels for alphanumeric and 6 pixels for the full character set. Way, way better than the whole pixel of everything in the iframe, right? Really, really fast. So here's another demo, same thing, same iframe, same everything. He's going to search for the CSRF token. He's calibrated for the font, and this is way, way quicker now. And you're getting a text output. This is not a picture output. So he pulls out Google ID. He's going to pull out telephone number, because why wouldn't your telephone number be in some iframe Google comment box? Another telephone number, because just in case they didn't answer the first one. And then, yeah, things like CSRF tokens and stuff could be in there. That could be really juicy. Seriously, if you like that stuff, it's really, really creative. Go watch his WhiteHat talk. He has a bunch of cool demos, but that's the crux of it. And he brought back a lot of stuff that we thought we fixed a long time ago. Okay, number 2. This is breach. So we saw crime, we saw peace. This is breach. Okay, this is, everyone needs an all-cap acronym if you're doing any sort of encryption research, apparently, right? So this is another HTTPS break. This one's definitely practical. Okay, this one has no need for millions of requests. This one, they said SSL gone in 30 seconds was the name of their talk. I think they did it on stage in like 15 or something like that. They were trying to be catchy or something, right? So this is Angelo and Neal. They're at Salesforce now, I believe. Some really cool research. So, backstory. So, crime. How many of you guys started crime? Last year? Year before? Something like that? One of those years. Crime was really bad. All right. So, any HTTPS traffic that was using any sort of request compression. So yeah, TLS or Speedy or anything like that was using request compression, crime was able to read it, no problem, and break the ciphertext into plain text. So So compression was the kind of key factor there. It's also the key factor here, so just a real quick overview of how this kind of compression works in the HTTP encryption world, right? So, this is the easiest example that I could possibly think of. So, say you take the whole source code of a web page and you're trying to encrypt, compress it. How they do it is the first time they see any given string of characters, right? So in this case, Googling the Googles is the whole string of characters. The common string that they're going to see is OOGL, right? So they see it a second time, and they're just going to actually replace that with a pointer. Go back 13 characters, go forward 4 characters. Okay, so this is how this compression works. Go back all the way over here, go forward 4, that's what's here, right? So if you do this over the whole source code of the page, it actually compresses a pretty significant amount. When you hear compressing a pretty significant amount, you hear faster, you hear cheaper, you hear all sorts of things that people like, right? So, part of the crux of this attack, this is actually, so this is on, the breach is actually on the response instead of the request, right? So, say you had some super secret thing in source code that you're trying to pull out, right? It's encrypted. And say you have some point that you can reflect into there and start guessing what that thing is, right? So, say it was super secret and you had all of it guessed except for one character, like this X at the end, right? It's going to compress down to this, right? Hey, you got all the characters right, so you go back 22, go forward 10, whatever, and then there's going to be this X floating on the outside. It's going to compress down to a certain size, right? Say you're brute forcing this whole thing, you finally get this lowercase t, right? It's going to compress fully, and wholly, it's actually going to be a measurably smaller size than the failed attempt. Does that kind of make sense? And I'll go through this kind of quick. But here's what's required, right? So similar to like reflective XSS or something like that, you need some sort of, they call it a canary, right? You need some sort of reflection. You need something that you're controlling in the source code. So, you know, some parameter in the URL somewhere reflects back in the source code, right? So they're using it as a canary, and they're going to kind of brute force. I think one of the examples they use, yeah, CSRF tokens again, right? I'm going to keep guessing this random CSRF token, brute force it, until the compression starts getting smaller and smaller with every character that I get right? It's going to successfully compress smaller and smaller. So, in order for this attack to work, you need to be using gzip compression on HTTP responses. I don't think I have the stats on this one. It's really, really prevalent. Most sites have gzip compression enabled on HTTP responses. It's really, really, really popular, right? You need, and obviously it doesn't matter which version of SSL or TLS is going on, but you need some sort of encrypted text. You need some canary, right? So the attacker's flag character, and it helps. This whole 30-second thing, it helps if you have a few characters known, right? So maybe the name of the token or something like that. You get the first 3 characters, and that would be pretty easy. I'm running short on time, so I'm going to blow past a few slides here. They did some sort of command and control server proof of concept. This really isn't that important for the vulnerability or for the exploit. This is how they kind of proved that they could do this in mass really, really quickly from a command and control server with all sorts of stuff. They have all this up. Again, this is a black hat talk. You guys can go watch if you're interested in this part of it, in the exploitation tool. But the real crux of what's going on is that you can just pull this stuff out real quick if gzip is enabled, no problem, right? So this just goes into how that command and control tool is working. And this was just a screenshot from them on stage pulling it out. So this is their command line tool that they were running, and this was the source code. And so they highlighted that they were able to pull out this whole seemingly random value into source code, no problem. Like I said, it took about, is it up here? I don't know, it took less than 30 seconds. And they had some really cool Mission Impossible music playing the whole time. It made it really up the hacker cred, right? So, yeah, again, that was just some example from the canary. Oh, okay, so it took 43 seconds. I thought their talk was titled 60 seconds, and it took 43. It was titled 30, and it took 43. They're obviously lying. Okay. So how do you fix this? What are you going to do about this? This is the easiest one. Well, easiest one meaning flip a switch. Don't use HTTP response compression. This goes away. That's really a non-go for most people. When people like Amazon start publishing research that the faster a page loads equals the more money they make, and they have hard data on that, this is a hard sell, right? So things that you can do, randomize the length of whatever you're trying to protect, right? So CSRF token, randomize it. If you could chunk the HTTP request, I think that's on here somewhere, right? Yeah, chunk secret separation. You can chunk the request in separate things. It's kind of weird, but it would protect against this. Dynamic secrets, that's the big one. So I wrote a blog post after I read about Breach about how we at WhiteHat raised the bar of what we thought was good enough CSRF protection. So what we used to think was good enough CSRF protection was if a token is generated every time you log in. It's a different token every session, and that's okay, because that session should be encrypted the whole time. But if you log out and log back in, it should give you a new token. That's no longer good enough, because if you're logged in and this exists and they're using HTTP response compression like gzip, you just pull that CSRF token out real quick, right? So if you're changing every request, which was the best of practice the whole time, right? But best practice versus good enough are two different things in the security world, as we all know, right? But now it's kind of, you need to do this dynamic every time in order to protect against this if you're using the response compression. All right, so real quick, real short on time. Number one, I should do these backwards, right? Number one, I should have a lot of time before. Anyway, this one's pretty easy. So, how many of you guys know Mario? He's my idol. Mario's this awesome. I think he's getting his PhD in XSS. I didn't know that's possible, but apparently in Germany that's a thing. Yeah, he's pretty hardcore academic in Germany that does a lot of XSS research. Definitely follow him on Twitter. Go look at he's got a bunch of HTML5 security cheat sheets that are really good. Go check out a lot of his research. Anyway, so this is Mutation. What was that?
Is that from Paris?
No, this was where he gave the talk originally. He gave the talk at some conference in Paris, but he's actually from Germany. Okay, so some assumptions here going forward of why this is cool. Right? In order to protect against cross-site scripting, this is everything that we tell everybody. Right? Input validate. Right? On both your GET requests, your POST request, input validate everything. Right? Use a strict whitelist to do that. Right? Neal? I'm going to put this up here just for Neal. You should stay for the talk after this. It's all about CSP, it's really cool. But yeah, CSP is pretty hardcore cross-site scripting protection, right? So okay, if you include that, and you have a strict whitelist, and you have all sorts of XSS protection headers, you should be good, right? Well, that's why he's number one this year. This mutation XSS technique kind of blew the lid off of all those assumptions. A little bit of history. As far as a little bit of history, it means that in IE something vulnerable was published. What? Who would have thought? Some IE version somewhere gave us something bad. Anyway, they gave us this easier way to manipulate the DOM of some website, which is inner HTML, right? Anyone who does web security, that's like you hone in on inner HTML stuff, you're like, holy crap, yeah, juicy, I'm going to attack that, right? But there's been a lot of protections that you can still use this pretty safely until Mario came along and broke it. So just if you have no idea what inner HTML is, here's really good, just like this is what it does that makes your life way easier if you want to do some DOM editing, right? So you can either do all of this or you can do this, right? And just start editing inner HTML and start throwing HTML into some frame or something like that you have a hold on, right? I'm not going to spend too much time on this, but just a primer, if you've never used inner HTML before, it's a really easy way to edit some stuff. So it's easy, it's fast, it's pretty much standard now, Nays, whatever, inner HTML stuff. Prevalent, it's super prevalent, right? So we did some Google code looking up and some GitHub searching, 1 million results in GitHub, 185,000 in Google. I don't know. Like, I mean, it's everywhere, right? It's really prevalent. Some more assumptions, right? What you give an inner HTML function, you would expect the same thing to be spit out, right? And then it's going to listen to you. You're going to say inner HTML something equals something, right? And you're going to expect on the other side that that's going to be true, right? Well, it's not. Browsers think we're stupid, and browsers think developers are stupid, and they try to fix things for you, like conveniently. Oh, you forgot to close this tag, we closed it for you, right? Oh, you forgot to close this quotation mark, we closed it for you. Things like that. And they do some other tweaking to save some time. This website, if you do any HTML5 or web app sec or web app development, this is a gold mine, right? This is Mary's website, html5sec.org. Consider HTML path is the one that has to do with this research specifically, but html5sec.org is an awesome, awesome cheat sheet of all the things that were introduced in HTML5 that really broke a lot of stuff. It was a really fun day for web app security researchers when HTML5 dropped. It was like broke every blacklist ever, and we all had a party, and we still all have jobs, right? So, okay, so quick demo. Again, if you're interested, this talk was on the URL on the front page. Go watch it if you want to see the crux of what he talks about, but just really quick demo. So what you're seeing here, right? This is the input. This is going to be the output, and then we're going to see what the browser does to render it, and the browser thinking we're stupid, right? So this is what we type. This is what we think is going to come out, and this is going to be the source that the browser fixes, right? So in this sense, right? We wrote hello world. It's the same in all places, right? So now we wrote some S tag, right? Going back to cool things we used to do in amplifiers, right? So we strike out something. This is what it looks like in the browser. Well, this is what you think it's going to look like. This is what the browser does. This is what it looks like again. Everything looks cool here, right? What if we forgot? Oh, we forgot to close that S tag, right? Oh wait, why is it still crossed out? Oh wait, they put it there for us, right? They closed the S tag for us. All right, how nice is that? What could go wrong here, right? Okay, so we have a simple div tag. It's got a class parameter with an empty string. Then we have foobar, right? Look, they dropped that whole thing. How nice of them. Class equals empty string, they don't care. Let's save time, let's not even put it there, right? All right, div class equals test. Hey, now it showed up, right? Because there's something in that string. Guess what's missing? Who can spot what's missing? Quotes. Who needs the quotes, right? Like, this works like this. Who cares? Now you put a space in the middle of that test. What happened? Quotes are back. Because there was a space, so it didn't know that that was a string, right? Okay, what if we put a tick in the middle there? Okay, tick's in the middle there, no problem. What if we put a tick in the front? Quotes go away, right? It's back tick. Put another back tick. Quotes still go away. Wait a second. When you do cross-site scripting, you'll start drooling at this point. Right? So these backticks are completely valid delimiters in Internet Explorer, and you can break out right here and create your own parameter and alert, and this is just really standard cross-site scripting from here on out, right? But pretty simple, right? But this whole he's got tons of other examples of this whole mutating in the browser, trying to help you out here, and the DOM, it opens up all sorts of DOM-based cross-site scripting that we didn't know about, right? He credits all these other guys for helping him, so I figured I would also credit all of them, but Mary's been the one who kind of threw it out there. All right, I'm really short of time. What we learned. What's old is new and improved, right? So we brought back browser history sniffing. We brought back reading the inside of iframes. We brought back all sorts of padding attacks that were made popular a few years ago. And just used in new creative ways. Like, who would have ever thought of this pixel-by-pixel reading of an iframe? Apparently someone did, and it was awesome, right? Encryption every year. I think the past 3 years, yeah. 2010, 2011, 2012, they took, some encryption attack took the #1 spot. This year it got dethroned by cross-site scripting, but it was still 3 of the top 5, right? So encryption research is really heavily respected in the community, right? These things are not only submitted every year, but they're voted to the top every year by the community. And creativity seemed pretty important this year, right? That pixel perfect stuff and some of the SSL down in 30 seconds took some serious creativity and looking into all sorts of things that were right in front of our face the whole time and using them in new and creative ways in order to break a lot of things. So I just wanted to thank the panel of judges that we have. This takes a pretty significant amount of time to read up on all of these things, and we gave them a list of 15, not even just the 10, and they had to read up and understand them in order to meaningfully order them into a top 10. So I thank these guys. They're They're busy every year, but and we're, come the turn of the new year, we're going to put this out again. If you guys follow me on Twitter, I'm sure you'll see me blasted all over the place. But please submit stuff. Excuse me, vote whenever we ask for the community vote. Like we get some complaints every year of like, oh, how did this not make the top 10? It's like, I don't know. Like, did you vote? Like, we don't order it, right? We don't select it. This is completely community sourced. So if you're interested in this stuff, please get involved. That's it. Do you have any questions? I've got about a minute.